And you can also add it to Model Builder. So you can add it to your modeling flowchart and use Model Builder for it. So this was an example of editing a mesh. And what we did here, we combined meshes and changed things. And this is as it's seen in ArcGIS. So I have some figures here. So this is an example of importing a big mesh. So I have my boundaries here, the islands, the land, the ocean, all in ArcGIS now. So we're bypassing SMS, so you can create a team out of your mesh, if you're familiar with that. Here's my nodes. And then you can use ArcGIS resources to edit, change, do things with your mesh. So you can bring in imagery, you can bring ArcGIS resources, and you can actually play with your mesh, just like you can do with SMS. And we've seen that, so we can do the link over thing. And we can also visualize storm surge using time-aware layers. That's the new thing that ArcGIS has since ArcGIS 10. So you can make animations. And you can do arcscene maps. And more importantly, we can start to now build flood maps, which is what I want to do today. So you can start to get actual flood maps in GIS format and say, Ryan's house is going to have 1/2 meter of water for Hurricane Irene, and things like that. And we can put things on the web. So that was a web viewer that is getting pretty dated now, but at the time it worked. So you can post your data now on the web using ArcGIS. And at this time there wasn't ArcGIS.com. ArcGIS.com allows you to put the data directly. 340 students are creating all kinds of web maps and sharing on Facebook and things like that now, as of today. So technology is evolving a lot. Other things we can do. As I said at the beginning, we can use this information to update our model. So here at this case study here, we were updating dune morphology. So this was done in this very island here where we had updated LiDAR information, and we would update our mesh using LiDAR information with GIS. So here's a 3D view of the dunes, what do they look like. And we can also run damage analysis software. How many people here are familiar with HAZUS? Okay, HAZUS is a FEMA software that allows you to do damage analysis. So if you prepare your flood depth grids, just like I have it here, you can then do damage analysis using HAZUS.
That was actually part of the reading.
It was?
Yeah.
Oh, there you go. So you guys should know that. Come on, you're killing me here. It's part of the reading. What it does is it uses damage functions. So there are functions that relate depth with the percent damage. You should know all about this, Reza. Come on. So you use geospatial information of business or houses, things like that. So you know where a house is. You created a raster that knows what's the flood depth at every given house. And then you can use a table or a function like that that tells you that a given house with a 2 feet of water will get 20% damage, or you'll get 80% damaged. And then you can create geospatial maps that will quantify the damage based on a given flood level.
So is that a metric we would use for our report?
That would be outstanding. That would be super cool. I think I have an example here. It is here. Yeah, that's a perfect metric. So what we did in this case study is, on top here it's a restoration project. So this is an actual wetland restoration project that people were building at the coast at the time. So what we did is we simulated a scenario without the restoration project with our AdCirc. And then we simulated a scenario with a bunch of restoration projects where we would change friction, we would change elevation, because they not only put plants, but they change the bathymetry, the topography. And we will then run AdCirc before, we run AdCirc with the projects, and we use damage analysis as a metric. And we then compared how things would change in terms of restoration. So that gives people information of, okay, it cost me $2 billion to put a restoration project up, but for a storm like Brett, which is a historical storm, that's the, the reduction in damage I'm getting in this area. So you can do that kind of playing around comparisons. Does that make sense? So that's actually a good metric. That goes way beyond, my water level instead of 0.8, it's 0.9. Here's a view of, that I skipped that. That's how what HAZUS MH looks like. It's not that hard to learn. There's a lot of documentation out there. So I'm not going to teach a class on that, but there's videos, there's things. You can also just run your own Python script or whatever script you want to run these functions within ArcGIS. So you don't even need to go to HAZUS if you don't want, right? Yes? Okay. Did I lose you guys, or is it still making sense? Okay. This was a division at the time. I don't think we're there yet, but I think it's worth talking about it. What we wanted to have is, by putting this interface on the web, we wanted to have something that allowed people to change things or do design that they wanted to do with a web interface that would then recreate a new 414, 415, 413 on the fly, submit a simulation, run that on Stampede, process that data, and give it back to you on your browser. And you could look at it and see, wow, if I put a restoration project here, my surge is, lowering by 1 meter. This must be really worth it for Hurricane Katrina. Or no, I'm putting something here does not make a difference at all. So that is where technology is there. We just never done it. But this is where I think things will go. I think you guys will see that 5, 10 years. We will be changing things on the web. We'll be running the models with the supercomputer underneath and giving back to you results on the fly. Okay, and everything is online. So there's desktop data and there's online data, and we'll use some of it. And as I said, even undergrad students are now putting data online. So you can do that, and I think I have instructions here how to do that. So web services are all over. The base maps are kind of web services. You can add data from your ArcGIS online. People are publishing data like crazy. You can consume that data in your GIS desktop, but you can also put this data out if you want. A lot of organizations have map services and web maps where you can go get data. So if you work in Houston or in Boston, you can look to see what they have. And you can consume that data within ArcGIS. And you can do it yourself. So you can create your own ArcGIS.com account, and you can publish data out. And you can put maps out and do things